this video, let's talk about a two-proportion z-test. Okay, so I've worked through the problem already to try and speed up the video, and you don't have to wait on me on writing. So let's get to it. So some AP Stat students wanted to know if the proportion of students who participate in school activities increases from middle school to high school. A simple random sample of 250 middle school students found that 103 participate in school activities. A simple random sample of 300 high school students found that 153 participate in high school activities. Is there sufficient evidence that the participation in school activities increases from middle school to high school at the 5% significance level? So with a two-proportion z-test in this situation, we're comparing two different proportions, the proportion of middle schoolers that do sports activities, the proportion of high schoolers that do sports activities. So we're going to try and argue how are these two different, okay? First thing I did, I pull out all relevant information from the problem, okay? That's before I go through any of these phantoms, pull out all the relevant information. So working through it, I pulled out my x1, n1, got a p hat 1. x2, n2, pulled out a p hat 2. There's a p hat c here. We'll come back to what that is here in a second. So running through phantoms, P-H-A-N-T-O-M-S. So phantoms, started by defining what are my parameters? What are we even talking about here, my parameters? So P1 is the proportion of middle school students who participate in activities. P2 is the proportion of high school students who participate in activities. So these two population proportions are what we're talking about. My null hypothesis, this is what we're assuming is true until the very end, then we're going to make some sort of decision on it and go from there. The null hypothesis, we're going to assume these two proportions of students who are participating in activities is the same. The proportion of middle schoolers is equal to the proportion of high school students who participate in activities. Now, what we are seeking to prove is there sufficient evidence that the participation in school activities increases from middle school to high school? So as we go from middle school to high school, does the proportion increase? So that would be arguing, is P2 bigger than P1? The proportion of high schoolers that participate in activities bigger than P1. So where this P hat C comes into play, we are assuming these two proportions, population proportions, are equal, okay? Proportion of middle schoolers in activities, proportion of high schoolers in activities, they are the same. So what we can do is these samples that I got from each, if I'm assuming the population proportions are the same, then surely the samples I got from each, if they're equal, we can pull or pooled all of these together. I'm going to combine them. This is where P hat C comes from. I'm going to combine my two proportions together, my sample proportions. So I took 103 plus 153 and divided by 250 plus 300. I get my new P hat C, a combined proportion of 0.4655. Now, before I could do this problem, I need to make sure a few things are in order so that my sampling distribution is approximately normal. I can do z-scores, whatever I want to do. So the assumptions are independence 10%, and we're going to deal with NP and Q. So independence, we're making sure, yes, both samples were simple random samples. Great, that's helping us with independence. Also helping us with independence is this 10% condition. Both samples are less than 10% of the population. 250 middle schoolers is less than 10% of all middle schoolers. 300 high school students is less than 10% of all high school students. The third one is definitely the third we really need to be careful about. So it's typically revolving around NP is greater than or equal to 10 and NQ is greater than or equal to 10. But what we're going to use in a two-proportion z-test is NPC, or P hat C, and NQ hat C for both. So I did N1 P hat C, N1 Q hat C, N2 P hat C, N2 Q hat C. And I already did the math and worked it all the way out with my P hat C. It works for all of them. So because all these are met, independence 10%, and my sample is large enough, we know we can move forward with our two-proportion z-test. So we're now ready to do a two-proportion z-test because the assumptions are met. Here is my formula with everything plugged in. So it's going to be a z equals p hat 1 minus p hat 2 minus P1 minus P2, but because they're equal, P1 minus P2, even though I don't know the numerical values for P1 and P2, I know if they're equal and I'm going to subtract them, we're going to get 0. On the bottom here, quite a big square root. This is P hat C, Q hat C divided by N1 plus P hat C, Q hat C divided by N2. So a little bit different with our standard deviation there compared to a 2 proportion Z interval. I did run this through my calculator. I did a 2 proportion Z test on my calculator. It helped me get through this piece here, and we get a Z-score of negative 2.29. Once we have our Z-score, the calculator is going to help us out a little bit here too with coming up with our p-values. So I drew a normal distribution, center at 0, standard deviation at 1. There's my Z-score of negative 2.29. The proportion of Z-scores that are smaller than negative 2.29 is 0.0109. So assuming the null hypothesis is true, the probability that I could obtain the difference in samples that I got, or smaller, should happen 1.09% of the time. So if the null hypothesis was true, I would be able to observe what we just saw in our sample proportions 1.09% of the time. So that takes us to our make a decision and state the context. With our p-value of 0.0109, we did have an alpha of 0.05. So since we're below that 5% cutoff, we are going to reject the null hypothesis. Our p-value is less than the alpha equals 0.05 significance level. Because we're rejecting the null hypothesis, that means we have enough for the alternative. So with the alternative, there is sufficient evidence to say that the participation in school activities increases from middle school to high school. So that's what we are trying to seek evidence for. We're trying to show that the participation and proportion of high school students in activities, P2, is bigger than 1. So we rejected the null hypothesis. We have sufficient evidence for our alternative. So a quick overview there of a 2 proportion Z-test. Pay very close attention to the small details, especially the p hat C's that run throughout.